All right, we are back. This is Calculus 1. We're in Chapter 5. We're looking at 5.5, substitution. This is kind of an important process. And I'll try to make it as simple as I can for you. So where are we? We're on page 24 of the packet, page 24. And so 5.5, if we want to reverse the process and integrate to get back to f of x, we would write both u and u prime. It is called du. All right, and so first, before we do anything, there's not a lot of room on page 24. You could maybe squeeze this on the bottom. But remember when we were deriving using this process. So if I had 2x squared all raised to the 7th power, and I wanted to do the derivative. So we're going back to derivative, just a quick derivative review. Remember what we would do. We'd kind of say, okay, we set that as u, 2x squared plus 1, and we would find u prime, that's 4x. And then we would do the derivative by using the power rule. We kind of say f of u is equal to u to the 7th power. And we would do f prime u and say 7u to the 6th. And then we would say, okay, well, we didn't have u, we had x. So now we would put that back in and say f prime of u. Oh, wait, times u prime. Ooh, times u prime, don't forget that. All right, so f prime of x, then, we would just replace this back in here, 2x squared plus 1 to the 6th, and we would replace that with that for x. And then that was it. You know, we'd multiply that out and say 28 x times 2x squared plus 1 to the 6th. Now, some of you got really proficient at this and didn't really need the u substitution to get through this step. You would just say, okay, I'm going to take that 7 and put it down there. I'm going to make that a 6. I'm going to write that out exactly. I'm going to multiply it by the derivative of what's inside. And just kind of use the chain rule, if you will, instead of using this u substitution. All right, but now we're going to use u substitution to integrate. So a couple of things you should know. There's 17 integration rules here. Let's highlight the ones. You should have these pretty much down pat. U to the n du. So number one, definitely you should have this mastered, memorized, what have you. Okay. Plus c, right? Number two, you should know that one. U over u. If I'm going to integrate 1 over u, that's ln the absolute value of u. Plus c. Number three, e to the u du is just e to the u plus c. So these 1, 2, and 3 memorized. 4, no, I don't care if you know that one. Let's do 5. Sine u du, you should know that that's negative cosine u plus c, because remember, you're saying the derivative of what gives me this. So it's not the derivative of sine is cosine, but we're doing the derivative of negative cosine gets you back to sine. So you should have that down. Number 6, cosine u du is just sine u. So 1, 2, 3, 5, 6. You should have those start. 7, we should know 7, secant squared. U du, you should know that's tangent, right? The derivative of the tangent, secant squared. Number 8, you should know that. Cosecant squared. It's going to be negative cotangent u plus c. I should know number 9. That is secant u, tangent u, du. That's going to just be the secant u plus c. And number 10, you should know. That is cosecant u, cotangent u, du is equal to negative cosecant u plus c. So these integrals, 1, 2, and 3, 5, 6, 7, 8, 9, and 10, you should have upstairs. All right. Let's look at what is this? The theorem 5.1, anti-differentiation of a composite function. Okay, let's take a look at how we do this to integrate u substitution. And there will be a little bit, it gets a little bit complicated as we go. It is calculus. Calculus is not the easiest thing to get mastered. All right. So, let's see. In the line, write this, g of x, g prime of x dx should equal f of g of x plus c. All right, so if you had f of g of x times its derivative, g prime of x, it should just be f of g of x plus c. You must have the derivative of the inner function in order to integrate. So you must have the derivative of the inner function to integrate. All right, and then what's going on here with u? They're just replacing f of u du is equal to f of u plus c. So they're basically saying u is g of x and du is g prime of x. So instead of writing it like this, they replace this with u, and then this is du. It'll make sense as we do problems. So let's look at some problems. On top of page 25, let me show you what they're talking about here. So they want us to integrate x squared plus 1 times 2x dx. And so look, if I know that u is the inner, we're looking at x squared plus 1. Now this is a pre-cooked problem, and you'll see it, and you're going to run into those. So du dx is equal to 2x. And now what we're going to do is we're going to multiply both sides by du. Because look. Again, let's just do a quick reminder. I won't do this every problem, but look, if I go d dx and d dx, and then this doesn't match that, so I do the derivative of u, which is 1, but then I had to multiply it by a du dx. This does match that, so I can do the derivative of that. It's 2x, and the derivative of that is 0, and I don't need anything there. So now that is how I ended up with du over dx equals 2x. Now I can multiply both sides by dx. So du is equal to 2x dx. All right. So now if you take a look at what they gave us for the integral, let's examine that integral again. This part is u, And 2x dx is du. So we've got both pieces. So identify the inner and the outer functions of the following composite functions. Oh, they don't want us to actually do it though. So they just want you to rewrite it and say, okay, look, that is the integral of u to the 4th du. That is what's going on. So they're not having us actually do the integral yet. All right, baby stepping us. Okay, so let's look at B. And C, and then on the bottom of the page, do we get to integrate down there? No. Working with du to get the pattern. They just want the pattern. All right, so this page is just kind of getting it all set up. That's okay. It's good practice. Write it down. We'll get there. All right, so take a look at B. We have plus 1 times 4 dx. All right, now notice there is no x on this one. So u is going to be 4x plus 1. Du dx is going to be the derivative of that, which is just 4. And then I solve for du is equal to 4 dx. All right. And so my integral is u to the 1/2 power du. That's all they want us to do for these. Let's look at the next one. Sine of 4x plus 3 times 4 dx. Again, u is going to be 4x plus 3. Du dx is going to just be 4. And then I want to solve for du. So du, kind of cross multiply if you want to think of it like that. 4 dx. And now I've got du and I've got u, so I'm integrating the sine of u du. And it's all right there. This is du, and this is u. All right. Let's look at D. We have 7e to the 7x dx. So we're going to say u is equal to 7x. Du dx is equal to 7. So du is equal to 7 dx. And I have that. They don't have it in order, right? They have 7 up there. But I can rearrange this. And so what do I end up with? I have e to the u du. And if you want to see it rearranged, you would say e to the 7x 7 dx, like that. And now there's our du, there's our u. All right. All right, guidelines for u substitution. So lots of writing here. Lots of writing. So step 1, let u equal g of x, the inner function. Step 2, is find du. This is g prime of x, the derivative of the inner function. All right. Step 3. If needed. Oh, if needed, rewrite the integral. That's not always necessary. So step 3, sometimes we'll have a little circle with a line through it. So you might, if needed, rewrite du so that it's part of the integral. All right, step 4. Substitute u and du into the integral. All right, and you may need to rewrite it in order to fit a formula in, so that might require a rewrite. And I'm definitely going to swap out for a new marker here. This guy. Giant. All right, let's look at 5. Step 5. Then you actually get to integrate. We haven't done that yet. We will integrate using an integration formula. All right, you may need to rewrite in order to fit a formula. So again, you might need to rewrite. Constant factors can come out. Oh, that was in the substitution. Sub u and du integral, you might need a rewrite, or I think that you might need a rewrite was actually supposed to be on 5. This is constant factors can come out. So here, this one was supposed to be, you might need a rewrite. I mean, you might need a rewrite on that too. But here also constant factors can come out. Constants can come out. All right. Number 6. Reverse substitute to be back to the terms of the original. Okay, so let's see. It says, working with du to get the pattern. So let's see what's going on here. We have the integral of x times x squared minus 5 raised to the 4th dx. So number 1, we would say u is equal to x squared minus 5. Number 2, we would say du, remember it's du dx, here we'll just do the work, du dx is equal to 2x, and then I want just du. So we're going to say du is equal to 2x dx. All right, so now there is a problem because I want this, I want du, that's great, but right now I don't have 2x dx up there. Do you see the problem? I got 2x, but there's not a 2 up there. It wasn't like a nice pre-cooked problem. So what I'm going to need is, instead of solving for du like I normally do, I'm going to actually go back and look at what I have been given, which is x dx, and I want to solve for that. So I'm going to divide both of these by 2. So instead of just du, I'm going to say 1/2 du is equal to x dx. Now, I have an x dx that I can substitute in here, x dx. So instead of just du, I'm going to put 1/2 du in there. And so the integral number 4 here. Oh, wait, did I skip 3? Oh, that was kind of step 3. Sorry. That was step 3. So let me go back up here. Step 3 is, if needed, rewrite du so it is part of the integral. That was the problem. They didn't just give me what I needed. They didn't just throw a 2 in there. If they would have said 2x dx, I could have skipped step 3. But since I only have x dx, I need this to look like x dx, so I had to actually divide the 2 on both sides. So when I do number 4, substitute u and du, I'm going to have the integral. I'm going to have u to the 6th power. Was that to the 6th? I had it written to the 4th. Oops. To the 6th power, so I have this. I have u to the 6th power. But I don't just have du, I have 1/2 du. And before I actually integrate, I'm going to take that and do a rewrite. And that's what I was saying. Like sometimes the constants can come out, or you just rewrite it. So 1/2 times the integral u to the 6th du. And now we're ready to integrate. But they don't want us to integrate yet. So we're not doing 5 and 6 yet. I'm just doing 1 through 4. All right. But this step does throw people off. Because they're like, wait, where the heck did that 1/2 come from? Well, the 1/2 has to be inserted in there because they didn't give us a nice pre-cooked problem with a nice 2 here. So it looked exactly like that. And I could just say 2x dx and replace it with du. So this is more likely what's going to happen a lot of the time. All right, so let's look at the second example of this. And again, this will make a little more sense as we push through the notes and you see what's going on. So part B on the bottom of page 25 here, x squared square root of x cubed plus 2 dx. Okay. So we're going to say step 1, right? U is equal to x cubed plus 2, the innermost thing. Step 2 is du dx is equal to 3x squared. So du is equal to 3x squared dx. And now I stop. I pause and I take a look. And I say, okay, they got the x squared for me. That's nice. They got the dx for me. That's nice. They don't have this 3 there. So instead of du equal to this, I'm going to actually make this x squared dx. I'm going to solve for that. So I'm going to divide both sides by 3. And now I have something that'll fit into the thing they gave me. I have x squared dx. I have an x squared dx up there. And now I got a 1/3 du. All right, so that was step 3, was kind of solve this out for 1/3 du. So this matches with what I have. So now here, we'll go one little extra step. We got an extra board here. I'm going to erase. Let's rewrite this x cubed plus 2x squared dx. And you can see this matches that, and this matches that. And so let's sub those in. We've got the square u, and we have 1/3 du. And now that 1/3, I'm going to pull out in front of my integral. And then actually, one more rewrite here. Lots of rewrites. And now it's ready to be integrated. All right. Okay. So here, let's do some actual, bunch of problems. And then hopefully this will make a tiny bit more sense. So remember what we're doing when we actually integrate. That's in the line above here, the general power rule. So we're looking at page 26. So page 26, on the very top of the page, just to give yourself a little reminder, n plus 1, n plus 1 plus c. And in the line here, what's going on when we integrate u? That is u to the n plus 1 over n plus 1 plus c, and n cannot equal negative 1. So that's really just the same as this equation. We're just replacing the x's with u's and du's. So we know we're doing u substitution. All right, so let's actually go through all of the steps this time. 1 through 6. So here we go. We got 2x squared plus 7 cubed. That guy cubed, that's cubed dx. All right, so step 1, u is going to equal x squared plus 7. Step 2, du dx is going to equal 2x, so du is equal to 2x dx. Now, stop to see if we need step 3. Do we need step 3? No, we don't need step 3 because they gave us 2x dx, and that's exactly what we have here, 2x dx. So we don't need step 3. Step 3 is unnecessary. Step 4, we can substitute in our u's. So we have u to the third du. Step 5, we can integrate. So add 1, so that's u to the fourth, divide by whatever that power is, 4, and then plus c. Now, this is where a lot of students make mistakes. They forget about step 6. There aren't any u's here. This is all x's. So we have to take this integral and put our information back in there so that it's correct. So 6 is, it's going to be x squared plus 7 to the fourth power all over 4 plus c. And that's our integral. All right. Okay. Well, let's look at b. 3x squared, the square root of x cubed plus 2 dx. So number 1, u is equal to x cubed plus 2. Number 2, du is equal to 3x squared dx. So I didn't write du dx and then do another step. You can kind of get used to just doing this. Now, check and see if this is it up there. It is. We got a 3x squared and a dx. We've got the two pieces that we need to create that. So 3 is not necessary. 4, let's pop in our u substitution. So we got u to the 1/2 power du. All right. 5 is, let's integrate it. So how do we integrate? We add 1, so that's 3/2 u to the 3/2, and then times the reciprocal as the coefficient, 2/3, plus c. Kind of crazy too. All right. And then number 6, put that back in. So we got 2/3 times x cubed plus 2 plus c. Oh, to the 3/2 power. Ooh, don't forget that. That's kind of important. All right. There's our integral. Letter C, skip that for now. That's coming soon. We're not playing with secant, syndicant. We're not doing trig right now for this, for chapter 5. All right. Let's look at evaluating x plus 2 7th dx. All right, so number 1, x plus 2, u is equal to x plus 2. Number 2, du is equal to 1. All right, we don't need step 3 again because we have 1 dx right there. 1 dx right here. So step 3 is a skipperoo. Step 4, substitute in u to the 7th du. Step 5, integrate u to the 8th over 8 plus c. Step 6, substitute back in 1/8 times x plus 2 to the 8th plus c. That's it. So after you kind of get the swing of things, these aren't that bad, I hope. Let's look at 3x minus 7 to the 5th dx. All right, so number 1, u is equal to 3x minus 7. Number 2, du is equal to 3 dx. Problem. They don't have a 3. So this time we do get to do step 3, which means I want to look up here what I have. I have a dx and nothing else. So I need to isolate that dx and divide both sides by 3. So 1/3 du has to be substituted in for dx. So I have to fix it. I didn't need that on this one because I had just 1 dx when I took the derivative. So that was easy. So this is less easy. So now number 4, I'm going to sub in u to the 5th, but instead of just dx is equivalent to this, so 1/3 du. So now I have 1/3 du in there. I'm going to pull that 1/3 out as a constant in front, u5 du. And now I'm going to integrate 6 over 6. That's times that, and then plus c. And then that was step 5. Step 6, remember to put back in. So many students stop there and go, woo, I'm done. I'll put an 18 on the bottom. I'm done. You're not done until it has x's back in it. So we need 3x minus 7 to the 6th power over 18 plus c. Now you're done. Alrighty, ditty. Let's take a look at number 3. Still on page 26. We're working through the examples. How are we doing for time? Okay. This one's going to be a little lengthy. All right, we have 3x squared, square roots of x to the 3rd plus 1. Oh, that's all under this root dx. Okay, let's do it. We have step 1, u is going to equal the innermost thing, x cubed plus 1. 2, du is going to equal 3x squared dx. We are in business on this one because look, we have a 3x squared dx, which is exactly what du is, so we don't need a step 3. Step 4, sub in, what do we have? U to the 1/2 du. Step 5, integrate, so add 2 halves, 3 halves, so u to the 3 halves, and then remember, multiply by the reciprocal 2/3 as the coefficient, plus c. And don't forget to put back our x's. We don't have any u's in this problem, the original problem. We just used that as a little placeholder to make it a little less confusing. Alrighty, Diggy. On to the next one. Number 4, we have the integral of 2/3 x plus 4, all raised to the 6th power, 7th power, 6th power. 6th power dx. All right, so 1 is u is equal to the innermost thing, 2/3 x plus 4. 2, du is equal to 2/3 dx. Problem. We have a dx, but we have a 1 dx. We don't have a 2/3 dx. So this requires a step 3 where I solve for dx. And so you're going to have to go into your sweet algebra skills, solving, multiply by the reciprocal, 3 halves. So 3 halves du is equal to dx. Now we have a substitution we can put in there. So 4, we substitute in u to the 6th, but then we also substitute in 3 halves du for dx. That's the replacement. So the 3 halves comes out in front. We do a quick rewrite. Put the constant out front, du. We integrate, that's step 5. So we have 3 halves times the integration, u7/7. And then plus constant. And now we substitute that back into there. Oh no, I might need a little more room if I'm going to fix it. Am I going to fix it? No, I'm not. All right. We're not worried about fixing it. All right. 3 to the 3/14, right? Because 2 times 7 is 14. And then instead of u to the 7th, we're just going to say 2/3 x plus 4 to the 7th plus c. Yeah, no, I wouldn't be able to fix that anyway without really plowing through another half, right, to the 7th power. That's a lot of figuring. And so, no, that's not what, that's it. That's it. Answer. Okay. Let's keep plugging away. We got number 5. Sines and cosines. All right. I didn't play with the secant one up top because that had the distributive property. This one does not. Let's take a look. So these can be tricky. Like, which one do I pick? Do I do the sine? Do I do the cosine? And let's take a look at it. We have the integral of sine to the 5th x cosine x dx. So if I pick u to be like this, it kind of is a giveaway, right? Because sine x to the 5th power cosine x dx. So 1, u is going to be sine x, and then du dx is going to be cosine x dx. And I just so happen to have a cosine x dx, so I don't need a step 3. So step 4 is u to the 5th du. I didn't need any fixing. They kind of pre-cooked this problem. So the du will just fit right there, and the u will fit right there. And now I integrate. And then I sub back in. Okie dokie. Here, you could, if you sub back in like this, sine x to the 6th over 6 plus c. And then I just rewrite. So 1/6 instead of divided by 6, and sine x to the 6th power. That's the shorthand for it. Alrighty datey. And I guess you would really need the parentheses. You could put them on there if you want to, but you don't need them. All right, and then the last one. Oh, I'm going to need the board for the last one. There's number 5. Let's take a look at number 6. We have x to the 3rd over the square root of 5 plus x to the 4th dx. Oh, yay. So let's rewrite this one first. Ooh, and there is one just like this on the test. Put a little star on the test. Like this one. Not exactly this one, but like this one. All right, so before I even do step 1, x to the 3rd, 5 plus x to the 4th to the negative 1/2 dx. So let's rewrite that as a negative 1/2 power in there. And that makes it a lot easier to say, okay, u is 5 plus x to the 4th. Du is 4x to the 3rd dx. And now we take a look. What do we have? We have the x to the 3rd. Nice. We have dx. Nice. We don't have the 4. The 4 is missing. So this requires a step 3, where we do du equals 4x cubed dx. And we divide by 4, And so now 1/4 du will be inserted in place of. So again, if I don't skip any steps, just so you can see what's happening, I have this, but let's rewrite it so it looks like this. 5 plus 4 to the negative 1/2 x cubed dx. And now look at what I have. I have u is equal to the stuff inside right there. And I have x to the 3rd dx is equivalent to 1/4 du. And so that is my step 4, is sub in u to the negative 1/2 and 1/4 du for the x cubed dx. Now I can pull that 1/4 out in front. And I have a nice clean integral to do. So 1/4. Add 1 to that, so that's positive 1/2. And then I'm dividing by 1/2, but that actually means multiply with the reciprocal, so there's a 2 there now. And plus c. All right. And now 2 times 1/4 is 2/4 or 1/2. U to the 1/2 plus c. You don't need, I've had students do that. They're like, oh, wait, I took the 1/4 times the constant and said 1/4 c. Don't do that. Because it's a constant. And so it doesn't matter if it's 5 times the constant or 3 times the constant. That's just a different constant. And so don't bother doing the distributive. Don't ever have a coefficient on the constant. It's just a constant. All right. And then let's remember. So this was step 5 was to actually integrate. And then step 6 is get your stuff back in there. So we need to call this 1/2 times 5 plus x to the 4th to the 1/2 power plus c. Don't forget that last step. And yeah, you could rewrite that if you wanted to. I mean, this is fine. That's fine. But some students are like, no. I want square roots. Nice. Fancy like that. That's fine. Same thing. I'll put a little or there. All right. There is one like this on the test for sure. So make sure you have your brain around everything that we just covered there. Page 26. All right. And now we're going to page 27, page 28, page 29. Page 30. Okay, hold on. I think we're going to do, yeah, that's 47 minutes, 26. Why is DU so important? Okay, we'll continue on here. We'll do page 27. Then I think we're gonna break. No, you know what? I think we're gonna call this part 1. We're gonna do a part 1, part 2. So we will do part 2 of 5.5. Call this one part